I'm 20 years old. I go to insurance company and, well, I want to purchase this insurance policy that I have some bad feeling. Well, so you have to be very reasonable over here. So we need a probability. According to the National Vital Statistics Report, the probability that the female survives the year is 0.999544. So this is a survival rate for the year. Okay, just for the year, not a long term. Okay. So again, I'm 20-year-old female. Well, I'm very happy, and I go to insurance company, and I pay for $300. So the company receives $300, right? Okay. So if something happens to me, so in other words, I die in that year, within the 1 year period. Okay. If I die, I get $200,000. Well, my family will get $200,000. If I survive, that's great, right? But I don't get anything. Just, okay, $300 well spent, and then just move on, all right? So, the question is, compute the expected value of this policy to the insurance company. So you are looking this problem from insurance company's point of view. So, let's make a chart. So, probability. And X over here is, well, probability that I survive is this large, almost 100%. For the insurance company, okay, this random variable X represents the money transaction over here. So X is $300 they receive. So I'm going to put plus. For the company, this is X, they receive $300. The other side story is a sad story. I have a very, very slim chance, but still I have a chance, I have a probability that I may die in that year. So what's going to happen? The insurance is going to give my family big amount of money, but that they pay the amount. So don't forget that you are going to put negative sign here, because for the company's point of view, they pay out big sum over here, so negative 200,000. Okay, so how we are going to find the expected value? Well, X times P of X, and you compute. So once you compute this, is going to be 299.8632. Once you compute this, these two will give you negative 91.20. So for me surviving the year, the company is making this. But for me dying in the year is resulting in this. So what is it? We are going to find the sum that gives you X times P of X. That is 208.66. You add them up. Okay? So we did it before, problem like this. The sigma of X times P of X, that is the expected value. How do you interpret that? Okay? From the company's point of view, if they sell, when they sell many insurance policies like this, so they find many female, 20-year female like me to buy the policy, on average, they are going to make $200.66 per person who buy that. But to say this, they cannot say just 2 policies or 10 policies they sell. No, they have to sell many policies. Okay, so as N increases, yes, ultimately it's going to be the expected value is their profit is $208.66. Number 9, almost the end. Determine the area, the standard normal curve that lies this. So we are going to use a calculator, all right? So here we go. To the left of z equals 0.35. So the area over here is 0.5, so z must be on this side, right? Okay, z is this area of left of z square over here, this area. This is 0.35. So what are you going to say? To the left of z, yes, that is 0.35. Yes, that is correct. So what do you do? Oh, I'm sorry. That's hard. Z equals 0.35. So what do you have to do? This is a 0, so it has to be 0.35 over here. I'm sorry, I was confused. Okay, so what is the area over here? So this area is the same as the probability that z is less than 0.35, correct? Okay, so go to, this is just a direct way, so normal CDF, okay? Normal CDF and find the area. So the area is going to be 0.6368. Okay. Oh, is it? Yeah, it's not normal CDF, right? Invert norm. Invert norm. Sorry about that. The area is oh no. This is just regular, yes. And you can find that. Yes. The other one is, the next one is to the right of z equals 1.78. Oh yeah, I read this equal sign wrong way. The left of z is 0.35, that's what I was thinking, okay? I'm sorry, but z equals 0.35, okay. Okay. What is the area to the right of z equals 1.78? Yeah, this is z squared, this is a 0. 1 sigma away, that is 1, so 1.78 over here, 1.78 to the right. Okay, well, that is, if you use a table, that one is going to be 1 minus probability that z is less than 1.78. Okay, so that is 1 minus 0.9625, that gives you 0.0375. Okay, the next one, part C, over here, is find z sub 0.15. What does that mean? This is not z equals 0.15, so we read z sub 0.15. That means to the right of this z-score, the area is 0.15. And we want to compute this z-value over here. Okay? So then what is that? 0.15 is here, so the other side is 0.85. Okay, the other side area is 0.85. So we are going to compute that. So we are going to use, if you use a table, you are going to use a table backwards, or if you use a calculator, we are going to say invert norm, second bars, invert norm, area is 0.85, and mu equals 0, and the sigma equals 1. So that is z score is 1.0364. So you may say z equals 1.04. Okay, if I ask you just 2 decimals. All right, so z of this one right now, we always to the left, right? We emphasize the area to the left of a certain z-score, but this how you will use it is different from our normal way of using it, and you are going to use this on a lot in chapter 9 and chapter 10, okay? So don't forget this concept. Well, number 10 is just the same thing, right? The number 10 is standardized test. Outcome of a certain state are normally distributed with a mean of 380 and the standard deviation of 42. So the way we are going to do is exactly same. Okay, this is kind of redundant, so I'm going to give you just answer. The middle 80%, middle 80% means over here is 0.4, 40%, here is 0.4, 40%, okay? So that is mu equals 380, so one is less than mu and the other one is more than mu, so that is 326 to 434, okay? So, just to look at this, the area to the left over here is 0.1. This area is 0.1. So again, you are going to find this invert norm and give this area 0.1. You get this score. Okay. Part B. Denver has a test score of 475. Well, the mean is 380. Compared to that, it's a very, very high score. But still, it's unusual, yeah? We have to be careful about this. Is it unusual to have 475 for the test? Okay. So, 475, you locate that. And this is 380, this is 475, and once you compute, okay, this portion of this area is 0.012, so which is less than 5%, therefore, yes, you can say unusual. Okay, having a score of 475 when the mean is 380 and the standard deviation is 42, that is a very unusual case. Okay, part C. What is the probability that a randomly selected student has at least 350? So at least 350, so that gives you 380 in the middle, and 350 at least, so the other way around, okay, over here, right, 350 or more, so that is 1 minus probability that x is less than 350. Once you compute that, that one is 0.7625. Yeah, you can use a table and the calculator is going to be very, very close to one another. Okay. Part D, what is the minimum score that puts in the top 10%? Top 10%, can you say that's a percentile language? Top 10%. So that means, well, so the minimum of this, minimum of the top 10% is the same as 90th percentile. Okay, so from here, yeah, that person is very superior over here, okay? This is 0.9, the area over here is 0.9. So you have to use what, to find this score, you have to use invert norm. And once you find the invert norm, that is x equals 433.825. That is, well, when you give a score, it's going to be just a whole number, so that is the same as, 434, I'm sorry. Test score is 434. Okay? And this is, by the way, this area is 0.1, so whatever this number, okay, this number can be written as like a z sub 0.1. Okay, same concept. Okay, well, we went over these problems. Yes, it was a lot of work. On the other hand, well, some, just repeated use of some concepts of normal distribution, okay, and this binomial probability stuff, and the sampling distribution. Yes, anyhow, you go over these problems and do homework problem for practice, okay? That one will make you really prepared for the exam. And for the exam, everybody is going to take the exam at the same time as we did in class, okay? So it is going to be on Wednesday from 1:30 to 2:45. So again, exam 2, Wednesday, 1:30 to 2:45. As if you are in class. Yes, I give you flexibility to watch videos, okay? Just any time on that day so that you can do homework in a timely manner. But taking exam is another matter, okay? All right, so everybody get ready for this. All right, thank you. See you later. Bye.